Liftport Group. We've been running these Dare Greatly space shows since about October last year. So thanks for joining us and sticking with us as the community that we're building grows. Really appreciate that. Couple quick announcements. As you know, we kind of focus on a show that's got kind of three components, right? We talk about space policy, we talk about money, and we talk about infrastructure in space. And we do that with three different kinds of shows. One is a policy deep dive into a document. We did that a couple days ago with Space Capital, and really looking at the new $6 billion that have gone into our industry in the last 3 months. So that seems like a really big deal, except when you compare it to artificial intelligence and general AI, that's $10 billion in that industry. And that industry is like minutes old, where ours is decades old. So, it kind of puts it in perspective. So we dig deep into a document. We sometimes do a news show, and our third kind of show is the kind that we're going to have tonight, where we have a guest who's going to talk about infrastructure. We've been doing this for a while. We've got some great speakers and guests on our channel. So I really want to urge everyone to go to our YouTube channel. Always, share, like, and subscribe. That's youtube.com/liftport. You can go to our Discord channel if you want to join our community. Definitely encourage that. It's small, but it's mighty. It's kind of fun. Our shows are regularly broadcast in Spotify, so definitely make sure you look at Dare Greatly Space. There are several Dare Greatly titled shows, so you want to make sure you get the right one. And if you want to stay up to date with what we're doing on Eventbrite, feel free to take a look at that. We've got some stuff coming up in the near future. We're hosting the Mars Coin Expo. I'll put a link to that up in a moment. That is the only cryptocurrency backed by physics. So just let that sink in for a second. I'm not normally somebody who promotes digital currencies, but this one's definitely got my attention. So we're happy to host them. This is our third time hosting them. We've got some kind of big stuff happening next week on Tuesday. I can't name who the speaker is, but the Space Frontier Foundation is kicking off their Pioneers series, Pioneers of Space Commercialization. We've now hosted 6 interviews. We will be broadcasting them on Tuesdays, this normal time, 5 o'clock on the West Coast, 8 o'clock on the East Coast. Those are great. We've had some really cool interviews. This first one kind of shook me up a little. I was pretty impressed by it. So really happy to have that. And had some good news today. The Space Frontier Foundation is actually going to expand their agreement with us. So that's good news. That's new news for us. And we've got several guests lining up for the end of July. We've got Les Johnson, author, director of NASA's Advanced Concepts team down in Marshall. He's doing a different project now. Fascinating guy, Johnson, really, really interesting guy. That's going to be fun. We've got the folks from Gravitics and Starfish going to join us here in the next few weeks. Just this afternoon, we got a commitment from some folks at ANSYS who are going to join us. So, it's been really fun scheduling these things, and there's some other stuff kind of in the works. So we'll get there I'm just told that Larry Lopin is going to join us on August 2nd. He is the creator of the Mars Coin tool. With that, I want to just get straight into it. I'm going to bring in Gary just a moment. Gary, hi, how are you? Nope, you just went silent, even though we just did a sound check moments before.
How's that?
There we go. Great.
Okay.
Great. Gary, we don't do bios on this show. I know that you have been on this show. You've been on shows of ours. I think this is the sixth time. Started out in the early days of the pandemic. It might have been October, November, December, something like that of 2020.
Yep.
And then over time, we keep coming back to you. Why do we keep coming back to you? Because you're growing. You're showing what a small space startup is really capable of. But in all of our other shows, I've read, a paragraph long bio. It's been interesting, but that's not what we do with this show. With this show, we dig deeper. In past shows, you've only had 20 minutes, 15 minutes, half an hour. This is an hour, and we're going to go kind of behind the scenes a little bit. So rather than me read off a boring bio, we want to spend about 10, 15 minutes digging into your origin story. So who are you? Where are you coming from? Why are you here? Before we get into the rest of the company.
Yeah, so I'm Gary Calnan, as you mentioned. Thanks for having me, by the way. It's great to be on again. Yeah, I know a lot of progress in the last few years, but where do I come from? I have, I originally come from Western Pennsylvania, which is kind of relevant in a way because now we're doing metal processing, and it sort of goes back to the old history of Pittsburgh as a steel town, as sort of the origin of Andrew Carnegie, which is kind of a nice tie-in for us because we want to be the steel mills of the next industrial revolution. So I like that connection. But I've been out in Colorado since 1996. But I always had this fascination for space. When I was a kid, actually, the earliest thing I remember, this is how I kind of got to this place. I remember probably back in the late 80s, maybe early 90s, there must have been a Popular Science article about moon bases or something. And I wish my parents had saved this thing that I made, but I had taped together like 18 pages of graph paper, and I drew out this like intricate lunar base with all the things that I thought should go on a lunar base.
Right.
And it really is kind of evidence of how I've had this interest since the early days of my life. But ended up going to the Air Force Academy. I thought that was my ticket to become an astronaut. I would go and like probably, I don't know how many other cadets have gone to the Air Force Academy thinking, I know, I'll get an astro degree. I'll become a test pilot, and then I'll become an astronaut, right? Like
right.
Check. That's kind of the traditional path, right? So I went that way, but while I was there, quickly figured out that maybe the military lifestyle wasn't quite right for me. Hadn't explored my young freedom prior to that very much, and I just kind of balked at the constraints that you get from a military environment. Ended up sticking it out for 2 years and 2 months, and left right before I would have been committed to stay, and went to Boulder, Colorado, and then ended up for a variety of reasons ended up getting into the Art and Sciences school instead of continuing in engineering. Actually thought that I could transfer to engineering. Because I was doing all these academic credits and it was doing well at the academy, be a piece of cake, right? And I get to see, and I just completely underestimated the difficulty of going from no freedom to absolute freedom as like a 19-year-old kid. So anyway, my grades weren't great that first semester, and transferring over wasn't really an option anymore. So I sort of adapted and pivoted a little bit in my own life, and decided to do economics with a business minor. And always had this eye on entrepreneurship as well. So this was, I had done some stuff when I was much younger, of course, like a lot of kids do, but But here's where I really started to try things out. Had some friends that kind of inspired me as well, and ended up starting my first startup right out of college. And that, in a way, was sort of my way of exploring that creative engineering sort of capability to sort of make stuff. And I created a company called Night Riders, where we drove people home in their own cars when they had too much to drink.
Right.
Sort of like, it achieved some of the goals that Uber does today, but before there were smartphones, before there was Uber, this was 2001 to 2005.
Okay.
And this was my first startup experience. And, it was a challenging kind of business to run. But in the end, couldn't quite make a profit at it. We did raise some money, kind of went through the whole life cycle of business, sort of scrappy bootstrap, get things going, then raised a little bit of money from angel investors, completely underestimated how much to raise, like all the mistakes that you can make as a startup, had to learn the hard way. It was like an MBA in real time. And then it went through that process. And at that, in that process, I was already had not that great a credit. I had like really literally nothing to lose. So it was all on the line. There was no plan B. It was just going to do this business. It's going to be massive. We're going to be multi-$100-million business. We had this map of the United States and all the cities we were going to go to. Yeah, exactly. And
you cannot be a timid entrepreneur.
Especially if you're trying to raise money at like 22 years old, like that.
No, I don't know any successful capital raise that starts with, I'm going to start small, right?
Yeah. From outside investors, that's just not how it works. But so yes, we did that, and it was successful in many ways. We took a lot of people home safely. We created this whole concept. We were able to get it to work and everything. But it was very hard to make a profit. And, we didn't have the, contractor model that Uber has today. It was employees, because we wanted to tell them how to dress. We wanted to tell them where to be and how to behave. So they really were employees, right? Yeah. And most people don't want to work for like 2 hours when there's this peak demand. So, we were employing people for longer than we needed them. And so they were underutilized in the front and back end, and they were, overutilized in the middle. We couldn't meet demand. So there's a lot of challenges just fundamentally to the business. But they go through the whole life cycle. We expanded from Boulder to Denver and went through the whole process. In the end, though, because there was no plan B, we just ran that thing until like people started turning things off on us, like until we hadn't paid our bills and they locked the doors on the warehouse where we kept our stuff, and our phones got shut off and all that kind of stuff. So it was a real like go for broke,
right?
And in the end, that's what happened.
Yeah.
And we, it was a very emotional, like challenging experience.
Give me those years. What years?
This was we operated from 2001 to 2005.
Okay, and you went from 19 to 23?
No, I started that business. I was born in 78, so I would have been 22, I guess, when we started the business.
Okay, 22 to 26. Okay, all right. That's
right before I graduated from college when we started the business. So
right
around that time.
Okay.
And
so I'm 26 and broke, right? You're 26. You've gone to the academy. Didn't like the constraints. Left. Went to school. Didn't like the first program. Shifted programs, and then created Night Driver. Is that
Night Riders is what we call it, because we rode around on motorcycles at night.
Right. Okay. I mean, that's a lot. That's a lot at 26. Nice job.
Yeah. It was a lot. I mean, it was fun. It was time of my life really at that point. But and then I had to go through the whole mess of experience of like, okay, now what's my identity after my business collapsed? And that was my identity, as a young startup founder, and sort of spent many years kind of recovering from that. So I went into the corporate world, did some consulting work for a consulting company, then moved into their finance department. I was really interested in investments. So I got my chartered financial analyst designation to manage equities and do the analysis and whatnot. Spent some time doing FP&A kind of stuff, and then went into a boutique asset manager for a few years where I was running their portfolio strategies and doing trades. So it was a very small firm. So we kind of did a lot of everything. Tried my hand at that for a while. Their strategy started to not work so great. So I left. I was about to have a baby. I left and tried to find a job that was, more like had more upward trajectory built into it. back in an FP&A in a SaaS software kind of role here in Denver. It was a company that was involved in workforce management. And so I ended up starting out as like a, I don't know, senior manager or something, ended up as the director of finance at that company. And then all the while, right around 20, I was still kind of tracking the space industry this whole time, trying to figure out how to get into it. Always sort of feeling like, there were moments where I felt like only 30% of my brain was being focused on the work that I was doing because I was kind of bored with this, just finance work for finance work. You have a question?
I mean, having an MFA, not Masters in Fine Arts, but financial analyst, that's a pretty rare skill in this field, right? A lot of people come in with engineering and they want to be managers. Me, I'm a manager that likes to speak engineering language, right? But a finance degree in this sector is pretty rare, right? How many MFAs in this field do you know?
I don't think I know any of. It's a CFA. I don't think I know any of the CFAs in this.
CFA. Right. So I'm gonna make an exaggeration and say 100 or 500 or 1,000 people in the space sector.
Something like that, probably.
How many are CFAs? Very, very, very few.
Maybe one or two, maybe.
Yeah. Right.
I could probably go through my LinkedIn and figure it out. But.
Right. But it's not an ME, it's not a double E, it's not a PhD, right? I mean, it's a pretty. So how? And we'll talk more about the business in a minute. But how did you springboard from a finance background to space? Now you say, okay, only 30% of your brain was occupied. You're bored. Okay, you're daydreaming. Space. How did? Because there's a lot of ways you could have gone, right? There's a lot of things you could have done that was not space. So
I considered going back to school to become an engineer. I'll start over basically because that was what all the cool jobs looked like they were doing. And you don't really see the other roles that you have in space industry advertised so much, from space companies. But I was watching, SpaceX do what it was doing around that time frame, and things really started to take off. I saw planetary resources and deep space industries were sort of well funded around 2017, 2016, and some of that stuff was starting to happen. And I really felt like, now was the time, and I desperately wanted to get in, but didn't know how. And I found out about the International Space University, and that really was my. It became the alternative to going back to school to become an engineer. And that was how I got my seat at the table. Okay, now there might be another way to do this. So at first I wasn't sure if it was real. I think this is a common thing that people feel like when they hear about it, but it's just not that well known. And it doesn't sound like something that would exist, but it does. And it's been around for a while. And I learned that from talking to other people who, have been through the program, did my due diligence, and decided it was worth attending. That was really, that became the next best time of my life because I spent 9 weeks kind of immersed in space. But that was my way of getting into the space industry. I used ISU as I kind of needed a reason to feel like I had a justification to sit at that space table. I needed a foot in the door, just for me intellectually. And I know in retrospect, I probably could have started the company and figured this stuff out, without going to ISU. But that was something that was really important for me to be able to do and get. And it was there that I went there with the intention to start a company. I wanted to get back in entrepreneurship. I wanted to start a space company. I had read Peter Diamandis's book, Bold. And reading that, also, I think might have been where I heard about ISU. And that inspired me to think actually, I don't need to be an engineer to do a space company. If I find the right people to partner with, I could do this. So that was the other piece that kind of inspired that path. And it was at ISU that I found my co-founders.
I am sure that ISU would love that endorsement and that acknowledgement. For those folks who don't know, I'm the past president of the U.S. Alumni Association for ISU. So I've been involved with the school for 15 years. Just before the call, I was saying I didn't have gray hair when I went to school, so that's a big change. I went in 2008 to the Barcelona program. So were you in the summer program or the master's program?
I was in the summer program in Cork, Ireland in 2017.
Okay. All right. So ISU runs programs around the world. They have what they call a floating campus in the summertime. It's 10, 11 weeks somewhere in the world. My class was in Barcelona. His was in Cork. They're all over. They're all over the world. They have a summer hemispheres program in Australia. They're doing some stuff in South America now. Yeah, it's a pretty interesting school. It's a wide but not deep education. It is a generalist education, and that's its strength. And hats off to it. Like, I was really glad to do it. I did something similar to what you did, Gary. I went to school after I had been working on the space elevator for several years. I'm like, there's stuff I don't know, and I need to get the broader perspective. So very cool. All right, so you went to ISU, went to a summer program. What happened there?
Yeah, so at ISU, before I had went, I actually quit my job where I was director of finance because I didn't want to. I didn't burn my boats, but I didn't want to be lured back in. I could have taken a sabbatical and come back to the job, but I knew if that option was open to me, it would have been pretty hard to pass up probably. So I quit my job and went there. Kind of in the beginning, first couple of weeks, I was just kind of meeting people and trying to see if anybody was interested in starting a startup. And I had previously decided that I wanted to do something that was big, that could make a dent in humans' progression into becoming sustainably off Earth. And I want to go to space someday. And so trying to make that happen and make the costs come down is important. So I was looking for something that was, I figured out while researching the school and in the background that the resources were going to be fundamental to making that happen. That was the first thing that needs to happen. And so when I was at ISU, I went around and looked for people who had similar thinking, and found a few people who were interested in doing this. Some of who are still co-founders of the company. And we literally just sat down in the room with a whiteboard, and we said, okay, value chain for resources. You have the extraction, and you have manufacturing. And you got people talking about making water, and that's the key material we're going to produce. And then, we'll also have some metals, and maybe we'll do something with that too. But that was kind of like an afterthought. Okay. But we sort of were like, well, you can't build space stations out of ice. You can turn it into oil for space or whatever, but you can't make space stations out of it. So somebody's going to need to kind of fill that middle spot of processing that material from extracted raw materials into something that manufacturers can use. Because on the other end of the spectrum, there were already companies doing manufacturing too. You had Made in Space,
Redwire,
some other companies that were talking about doing in-space manufacturing. You had a bunch of mining companies and some lunar landers that were all talking about extraction. So we saw that as an opening. I also learned about space debris. Really, I knew about it, but only a little bit, and I kind of realized the scale of it. And we sort of asked a naive question because, coming completely from the outside, why don't we mine the space debris first instead of trying to go after asteroids, because it's already refined metal and we know where it is. Obviously there are some challenges, in terms of orbits and that sort of thing. But that was the question we asked, and we asked that to one of the co-founders of Made in Space when he was doing a class with us, a presentation to our class, and he's like, yeah, I've been wanting somebody to do that. That would be great. If you can make materials, we could probably use them. So that was not all we needed, was to say, okay, this will be the first thing we make. We'll use that as a way to develop the metal processing capability in space. And then when the asteroid materials and the lunar materials become available, we will already know how to process metal in space. Right. And also we can make this thing valuable that's currently just a big, cleanup project. And that might close the economic loop on space debris removal. So that sort of kills two birds with one stone in a way, and makes the whole project more valuable. So that was how it started originally.
Okay. Is that about the time when you kind of did this, I'm going to call it a divergence into Luxembourg? Because you were waiting on Luxembourg for a long time.
Yeah, that's right. So I was the only American on the co-founding team originally.
Yeah.
So bringing the rest of the team to the United States seemed very difficult.
Right.
And Luxembourg had just announced their Space Resources Initiative. So we're like, well, maybe being a small fish in a small pond is better than being a small fish in a giant pond. So we could take our chances at Luxembourg. It's very targeted to what we're doing. They were right down, right in Europe. And they had right at that time when we were leaving ISU, they had a contest, space exploration masters contest, that was all around resource extraction. So let's just throw our idea in there. Didn't get very far because it was pretty immature at that point. But one of our classmates got all the way through to the finals. I don't think she got to the very final round, but she got through most of it. And she told us what they did when they brought her to Luxembourg and how they introduced her to these people. And also, just coincidentally, Gary Martin, who was one of our advisors at ISU, had just moved from NASA, or was about to the Luxembourg Space Agency, or Ministry of Economy at that time.
Right.
And so we're like, well, we know somebody over there. We can get all those meetings. So, we just went and recreated our own meeting schedule right before a conference they had. And they liked the idea at a high level. And so, they encouraged us to propose it to their Luxembourg Space Agency as an investment opportunity. And we went through a few rounds with them. The idea was different than it is now. It was much bigger project. We were talking about building like a 5,000 kilo platform in GEO, and it was going to be it would have been like $1 billion project.
Right.
and this was okay, but we didn't have any money. We didn't know really what we're doing. So they're like, I don't know, we like the idea, but this is a bit ambitious. You need to have extra revenues and stuff. And we hadn't figured out how to make it smaller. So we went through a few rounds with them, couldn't quite get them over the hump. And then we decided to move the company to the United States.
I think that's when I first encountered you, right? I think it was an ISU connection that started our conversation.
Yeah, possibly.
Right. Long before we were doing the media stuff, it was really focused on building out a Lagrange, for us, building out a Lagrange station, and then harvesting what we can harvest. So
and lunar elevation was the idea then. I remember right. Yeah.
Yeah. Okay. So what year is that? That's
we moved the company in 2019.
2019. Yeah. Okay. So then the world caught on fire in 2020. So let's talk about 2020, right? Where were you? Biologically, physically in the world. Where were you, mentally, emotionally, and where was the company at?
Yeah, so I was in Denver, and the company had gone through 3 rounds of cycles with Luxembourg. We had been turned down, but they kind of you can apply again. And we're like, okay, 3 is enough. We get the idea. So we decided to come to the US, but we had not figured out how to move forward at that point. I mean, honestly, the company could have easily been shut down then. We were at a point then when we were looking into, what if we do e-waste recycling? Maybe we'll need that refining capability, in space. And so that fits to the puzzle, and it's a terrestrial application. But it was really hunting around for a terrestrial application because the market was not ready to do this yet. It was still a little early. And
we haven't actually talked about what you're doing, so just kind of keep that in mind when we're talking about that.
Oh, right. Yeah. So, we were trying to develop a technology to melt down and process space debris and turn it into materials for manufacturing, basically. Is the long and short of it. And so we're building what we call a space foundry, and that was still the idea then. It was this large scale space foundry. And so anyway, we were trying to figure this out. We knew we would need a refining capability at some point. We wanted to have one so that we could not just melt things down, we could also separate them into different elements and then reconstitute them into different alloys and so on. So at that point in time, we were kind of floating around trying to figure out the right path forward. I think we had also gone through CDL partially at that Creative Destruction Lab, which is an accelerator. We went through 3 rounds of that. That took us down another windy path. And, around that time, everybody kept telling us, you guys have something here. You just have to figure out, maybe you need to put it on the shelf for a year or something. You and other people were saying, this is something that's going to be real. And we knew it was something. And then in 2020, in March of 2020, I had built a relationship with Angel above Madrid at Colorado School of Mines because they have the Space Resources program here and they're right down the road. And so he had a student in his class named Joe Pawelski, who is now our final co-founder and the CTO of the company. And he was taking his, certificate course there. He wrote this paper on doing aluminum extraction on the moon, building a smelter on the moon, what it would take.
Okay.
And I was like, hey, you got to meet Gary. You guys both want to melt metal in space. Like, you're right down the road, and he lives in Fort Collins. So anyway, this is March. We got introduced like right at the beginning of March in 2020, and then pandemic hits,
Right.
and we never met in person that year. And so we started working on. We were still doing this, toying with this e-waste idea. We were trying to make that a real thing, but then we did a NIAC proposal for the Space Foundry that didn't get accepted. But then because of the pandemic, NASA pushed earlier their SBIR schedule, and they released a topic that was all about salvaging and recycling metal from large objects not on the space station. Okay, I'm like, what the hell? We've been talking about this for years now. Like, it's like they read our minds, but we didn't talk to anyone at NASA about this. This was just like, lucky. And also at the same time, Made in Space and Tethers had both been acquired, so they were off the table for applying for this funding, which might have been who it was written for. I mean, I don't know, but so we ended up applying to that, and because Joe is like this classic maker, he's a mechanical engineer, he's a businessman, like he knows how to write these proposals. He hadn't done it before, but he was better at it than we were. We wrote the proposal, got accepted, in February of 21, and that's really what kicked it off. And Joe also had, a old friend who was also an angel investor and had made.
Wait. February 21 was when you submitted.
No, we submitted January. We submitted like right at the end of December of 2020.
Okay.
And then we got notified, I think, late February of 21 that we had.
That is when we had our first on-screen interviews. So that was happening.
Okay. Yeah, we would have gotten accepted probably after that. I think we were expecting to hear about it. And then we got this deal. One of this friends and family kind of investor, our first investor, came in, basically matched the funding that we got from NASA.
Right.
And that allowed us to go. Me and Joe became the first full-time employees in May. That's when we both quit our other things we were doing for money, and we went all in as some of the contractors. We had Nanoracks on board as well as a subcontractor, and we went and we had Mines, that was a crucial subcontracting partner as well. And from there, and that's the first phase one. We went from concept to working prototype in October of that year, in less than 6 months.
Right.
And we built it. We did a demo in front of audience of like 120 people online, in person, in Australia.
Right.
We had Neumann Space on that one. We had Astroscale, Nanoracks, us, and Neumann Space. We did the whole end-to-end demonstration of theoretically capturing debris. We made a rod on stage, and Neumann Space fired it up in their clear vacuum box and showed how it could make thrust. And so that, like, getting that much success out of a phase one, I think really helped us get to the phase two. And really, since then, the NASA phase one is really what set the company in motion, from just pitch decks to actual building stuff and making real hardware. And since then, we've become a company that makes stuff, builds stuff, iterates quickly.
Right. That's the recipe for success. Make stuff, build stuff, iterate quickly. Let's go a little deeper into that demo, because it really was a game changer for you. We've hosted a similar demo on our channel with y'all, but go through that. Who are the partners? What did you accomplish? And then partner A hands it to partner B, to partner C, to partner D. Give us that value chain for a second.
Yeah, so Astroscale was on the front end. They were
right. So Astroscale, well funded now. We're not well funded at the time.
I mean, they were much better funded than we were, but
but they're not. They weren't at the level that they're at now.
Much more well funded now than they were then.
Yeah.
But they had just opened up their Denver office, I think, or they were about to. So it's kind of around that time frame. They had people in the U.S. at that point, which is in Denver also.
I know the answer, but what does Astroscale do?
Yeah, Astroscale does debris removal, and now they've also expanded into satellite servicing, and so they kind of.
So they're going to go out and find stuff, right?
Correct. So their role was to be the trucks that go out and get the materials.
Okay.
Go get the materials. Nanoracks, it was at that time they were focusing on two concepts that were relevant. They had their cutting technology, which was related to this Outpost program, which was all about taking existing upper stages and turning them into modules, or like extended platforms for doing stuff on. So they were about to test this cutting technology, what they have now since tested in orbit. But anyway, they did a presentation. So Astroscale presented on capture, NanoRacks presented on cutting, as well as the Outpost program, which would be a great place to host, this recycling concept. And then we had our machine, which was our first prototype, which had this like investment casting system. I actually have like samples from that one here with me. So this is like a little ingot basically that we cast in a mold. That was, we used a strip of metal that went down. We melted down the metal, cast it in a mold, and popped out a rod. And I stood there and like acted like I was the robot arm, it's going to take it out. But yeah, it almost got stuck, and we had a backup plan, like if that was going to happen. But gave it a little wiggle, and it finished its process. And we made two rods there on stage, and then we handed it off to Neumann Space over Zoom, and they were the ones who we had sent them a rod ahead of time, which was like one of these, and had a little hole drilled to the center. And the way their thing works is it has a spark maker on top that turns the metal into plasma, and that works a plasma thruster. So we had sent it to them. They fired it up. They showed that we could basically take that debris that we had melted down and turn it into a rod and use it for propulsion. So we have captured space debris, use it for propulsion. And what that unlocks in the the solution set for space is that means you can take a fraction of the mass of a debris object, turn it into propellant, and use it to go get the next debris object. And you have material left over that you can use to build stuff with, or sell propellant to Space Force or whoever. Actually, that whole concept is what our recently awarded Space Force Director Phase 2 is all about as well. So there's definitely some crossover from these concepts. Some of the same
people. Amazing. All right, so that took you from 3 people with part-time gigs trying to kind of make this thing work to where are you at now? You just told me just independently, but that took you from 3 people to what?
So that project was 2 full-time, me and Joe, and then we had a couple of like consultants helping us as well. And then the co-founders, the rest of the co-founders were, Walter and Toby, who were over in Europe, were still involved as well, but they were working other jobs. And now Joe was the other co-founder, and Kai Stats is also a co-founder of the company too, and he was involved in the company at that time as well. And so we were the co-founders basically. At the end of that, really and very importantly, this guy Steve Ward came on board just to kind of help out. He had moved to town. He knew Joe through his hobby of Tesla coils, and is kind of is an inventor on that side. Master at electronics, and so he came on and was just kind of helping out with the demo, and then started to help Joe out with more things, and took our power electronics that we had for that system from a box that was like a toaster oven down to this little card size thing. And so that was a kind of amazing breakthrough between SBIRs,
right?
And that has led to some other opportunities that are happening now. But that took us into, at the end of your phase 1, you proposed at phase 2. We were, two full-time plus co-founders and some contractors. Then we got our phase 2 from NASA, which we found out about in late February of 2022, and started working on that in May of 2022. And still at that point in time, we were just a few people. When did we bring on Lee? Let's see, it's 2023. So I think it was, around that time, I realized I needed some more help. And we brought on Lee Steinke, who was our first executive level hire, oil and gas background and getting into the space industry. I know you know her. So she came on and
I think I pointed her your direction. I think it's
awesome.
I don't think it's I know her. She took over my job at Conversations for the Future. I was the host for the Foundation for the Future. She took over that role. Peace out. But I was just super impressed by her. and she was trying to figure out how to get into the industry. And I'm like, call Gary. I'm 100% sure that that's the
awesome. Well, that's great, and I appreciate that because she's been an amazing part of the company. So she came on as a kind of a consultant at first, helped us through some really chaotic applications and things, which was a great test for whether she really wanted to hang out with us or not, and she liked it. And then she joined us full time in April of 22, I guess. It's been a little over a year that she's getting closer to a year and a half. That she's with us, and we had raised a little bit more money at that point. So about that time, we maybe had raised $300,000 or so to augment what we were getting from these government contracts. And we went to Seraphim Space Camp that year as well, and we sort of started work on the NASA contract. So now we're 3 full time. Yeah, I think that's right. No, and Steve was full time now too. So we were 4 at that point, and started going into the NASA contract. And that was, I guess, summer of 2022. We went through the Seraphim Space Camp. Over that summer, we closed out our pre-seed round, raised $665,000 in that. Got a grant from the state of Colorado at the same time as well. And so that allowed us, all those things, had allowed us to grow the company even more. Today, we are 12 people. So we've really, and like that last year, we did $220,000 in revenue, from that NASA contract mainly. And this year we're on track to do 2.2 million. So like it's been a massive growth in the company.
God, that's amazing. I mean, sincerely, congratulations. I mean, to kind of like, in this industry, it's pretty hard to have a plan, execute to plan, and succeed, right? So to go from, I can really visualize you hanging out with your buddies at ISU. Maybe there was beer involved, because it's ISU.
Maybe daily, yeah.
Maybe,
also Ireland.
Maybe there was beer involved. Maybe. I'm not putting you on the spot. I just have a hunch.
Yeah.
But imagining like, okay, what does this future look like? Okay, we want to do resources, or we don't want to do resource extraction. We want to do resource refinement. That's a hole out in the industry. And then step by laborious step, you get there. That's remarkable. That's remarkable.
I mean, we're not doing it in space yet, but we are working on an opportunity to do it in 2025.
Yeah, I'm gonna post one of the images. Let's see.
Oh yeah, that was the thing that happened last year.
Yeah.
As part of our NASA project, we wanted to test out the next version of the system in a parabolic flight. So that was part of the plan. And that's us doing the parabolic flight back in November. So we actually have flown what you see here on the two machines you see. On the back there is the casting portion of the machine.
Okay.
And what you can't see on the inside of is this other box. So that the guy in front of the box sitting down is Steve Ward. Chris Fisher is also back there in the corner, right behind me, and he was running that casting machine as well. So there's a casting machine, and then there's another machine that does multi-coil electromagnetic induction to control the melt. And the idea there is that when we get
I saw that was just astounding.
Right? Say it again.
The melting.
Oh yeah.
Coil that you did live on screen was pretty astounding. And so you've taken this hard natural state piece of, was it aluminum? What was it? Well,
it's just 6061 aluminum, a pretty common material.
So just a standard bar of aluminum.
Yep.
Used this induction coil, melted it into slag, and then reshaped it into something else. Now you've done that on 0G, right?
Yeah. So we had our first experiment in 0G doing the next version. So that first one was in what they call investment casting. So casting into a mold, right? Now what we're doing is building a continuous casting system. And the idea there is that if it's continuous casting, on Earth, they use that to make things like railroads and stuff that's long. And so on Earth, you have molten metal in a vat, and it flows down through a some kind of rolling device that changes its shape, and then it runs down the line and cools off. The goal is to make when it changes its shape and freezes the outside shell. You freeze the outside shell enough to keep it from changing its shape back to a blob, but inside is still molten.
Right.
And also in space we don't have the benefit of gravity, so we need another method. So I'll talk about that first, and then I'll talk about what happened with the melting. The coil system we have now is a multiple coil system, and the idea there is that we can actually control a magnetic minimum inside those coils contactlessly, and then with another coil we can melt it, and so that it melts the molten material, and then the other coils control its position, and that stands in for gravity in this process. So it both heats the metal and moves it through to the continuous casting wheels, or the mechanism we use to cast it with, and then that rod gets formed. When we did this on that version, we had two wheels that were basically like pulleys. So think about two pulleys coming together and make a circle shape in the middle, and that's where they freeze. But the line that's actually freezing them is very thin, and so it has to be very precise, the timing and the temperature and the speed and everything. And you only have 20 seconds or so on these parabolic flights of microgravity, which we thought was enough, we calculated was enough, but there was a little delay in the thing getting started. And so by the time it actually started to push molten metal through the wheels, we only had a few seconds left of micro G. So about like this much of it got cast in 0G. Okay. And then we did hyper G, and there's all this molten metal inside this little shell, and it's like this. and the rest of it cast, but it was casting under 2G, basically at that point.
Okay.
So Chris, like a superhuman, was standing there in front of this machine under hypergravity, like taking off the wheels, like undoing parts, stopping during microgravity, you can't do anything, and then basically putting it back together again through a couple cycles of the flight. And we tried to run it again. There were some other issues, but like these things, the point of these things is to understand the parameters that you need to change and adjust so you can get it right the next time around. So we have another one scheduled for upcoming at the end of November this year as well.
Nice. If you need anybody to like carry luggage or just,
yeah,
I want to do a flight.
Oh, I mean, you need to do one. They're so amazing. Yeah.
All right. That's a remarkable story. All right. So that's kind of where you've come from. We always talk about money here. So, non-dilutive capital, other people call them contracts, revenue.
Yeah, right.
How much revenue in total? Broad numbers, but give us something we can use.
Yeah. So far, you take the pre-seed money and the government contracts. We had $250,000 in a grant from the state of Colorado. I mean, that's most people wouldn't call that a contract, I guess. We had our pre-seed revenue investment, which was $665,000. You add those two things together with our two contracts we've now won, which was $125,000 from phase 1 with NASA, another $800,000 in phase 2, and we just won a $1.7 million contract for direct to phase 2 from the Space Force, which started in March. So all that together is just under $4 million in contracts. And then we recently had our first commercial sale of this power converter product that has kind of spun out of some of this work as well. Which is smaller dollars. I can't talk much about the details on the value of it, but it's still our first sale of an actual product for commercial purposes. So that was pretty exciting as well. But.
Still, I mean, basically 0 to 4 million in, call it 2.5 years.
Yeah, basically.
2.5 hard, lots of work years, but still. I mean, that's the kind of story that, individually, I have a small company. Once upon a time, you and I talked about how similar our companies were, right? Just to see you just jump so far in such a short amount of time, it gives me individually, it gives my team hope, it gives an industry saying, okay, there is a path. If you have the right niche, the right product, the right team, there's a path to grow the vision from, I'm going to say, a drunk whiteboard at ISU into a real company with a real team with a real chance of changing the future. So,
yeah, a lot of stubbornness going into that one.
Yeah. It costs, right? This is a journey of of joy and frustration, of
Mm.
commitment and determination. Yeah, there's a cost to it for sure.
Yeah.
All right, so what's so that's where you're at now. You're doing a direct to phase two for Space Force. You finished the NASA phase two or not?
So the NASA phase two officially ends in a year in May, but
Okay.
we are already like way ahead of schedule. So we've pretty much done most of the work there. Colorado School of Mines is a huge partner on that one, and they're still working on the detail, some more work for the coil architecture and the math around all that, making that actually work well. But we're that is kind of wrapping up. We have the next parabolic flight, which is actually outside of that program. That's kind of run out of our other funding opportunities as well. But so that's happening. We also have had some really amazing and kind of surprising benefits from this power converter. If I could talk about that for a second, because that
Sure.
addresses one of the key financial challenges for startups in space, especially all startups to some extent, I guess, but in space it's a challenge because like this is especially at this part of the space economy, it doesn't have there's no commercial market for materials yet,
Right.
out in the future, and we don't know exactly when it's going to come. Like that's sort of a big unknown. The government is interested in these technologies because we need to have them ready when we need to have them ready. You got to start now,
Right.
But to find a way to get across that gap, we have to find some sort of today commercial revenue, so you're not just dependent upon burning investor capital constantly and giving away more equity in your company.
The investors don't like that plan, and they don't keep funding it.
And they won't. Often they won't invest in it if that's the plan anyway. It's too far out, right? And so we built this power converter. I told you how Steve was like instrumental into shrinking it down, right? And he had this, kind of outsider's perspective on how to architecture that thing. And so we built this power converter for our furnace because we needed to take a DC current, turn it into high frequency, high power AC current. And we were, at CSU with Neumann Space, like talking about how we were going to make propellant for their thruster. And we were talking to the experts at their propulsion, their plasma propulsion laboratory up there. And the guy's like, this thing is a lot like a PPU for electric propulsion. Like you could just like add a couple of this and that. And like, this would be kind of an interesting electric propulsion system, if the numbers work the way you think they are. It's like, oh, that's cool. So we sort of investigate that a little bit. And because Steve is a brilliant maker also, he's like, yeah, let's just like try something out. Let's make a PPU and run a Hall effect thruster in the lab and test it out.
Sure.
And so back in February, we did exactly that. And it worked at like 98% efficiency. It's got a great, mass and size factor, better than what's out there on the market. And crucially, it's high power. So we've learned that there's a lot of COTS, power units you can get for, 100 watts, 200 watts kind of systems. But once you get above 500 watts, 1,000 watts, there's not a lot off the shelf. And these PPUs are made, bespoke for these projects, and they have to get qualified every time. And like they're, it's expensive, and there's not a lot of suppliers for these things apparently. And so we thought, well, there's something there. It works. We'd also talked to Safran at the IAC in Paris the previous year, and they were kind of interested in this idea a little bit. And then we talked with them again, and so where this is all wrapped into is we have been able to now. We have it sold for a more of an ISAM solution that's going to be delivered here soon over the summer, which will be the first.
ISAM is in-space assembly and manufacturing.
Yeah, something along in that ballpark. And then for Safran, they've followed through with this interest they have. And recently we had them here in Colorado. They brought over one of their 1.5 to 2.5 kilowatt size power thrusters, their Hall effect thruster, which is electric propulsion system, and they wanted to see if we could integrate that with our PPU concept. And what we designed it to be is this sort of what we call it a modular configurable electric power converter, which you could say is MSEPC if you spell out the letters. But anyway, the point is that it's modular and scalable. So each of the key components of that power converter are like Lego bricks. If we want to make it bigger, more power, we add more of them in, or we add two of them together. There's different ways you can configure them to address a certain need. Add a new thing on the end. And what that allows us to do is to qualify each of those units once And then when we want to build a different unit, we don't have to qualify the whole thing all over again. We just qualify the new part, maybe the combination a little bit less, severely. And that helps to save money and save time for the people who are selling these things. But so Safran has come over, and now we have that system for the next few months. We're going to develop this into a full-scale PPU, and hopefully address the U.S. market with this combined offering going into the next couple of years here. So and since then we've been approached by a couple other companies that have a need for PPUs, and it turns out that this is like a pretty lucrative potential market when you get higher power things. And this seems like the path forward for us in the next to actually generate commercial revenues over the next couple of years.
Amazing. All right, so you went from call it nothing to something
Yeah,
pretty quickly, and now you are something, right? You are trying to build out this the alliances with Astroforge and Nanorax and Newman. No, it's not Newman, is it?
he says Neumann. It depends. He says Neumann, so I try to say Neumann now.
Okay. So you've got those alliances. You've got the School of Mines. You've got Safran. Like you've got Air Force and NASA. Like all of these partners are starting to align. So we only have about 4 minutes left. Where does this take you? Push out to 2025, push out to 2030, and push out to 2035. Where do you think you're going to go in the not too distant future?
Yeah, so we see the opportunity to develop out this power converter business as sort of a separate line of business, and bring on the right people in the capital to be able to do that expansion over the next call it year or so. We'll see how fast we can actually bring this combination to market and stuff, but hopefully by 25 we've got some solid offerings in there. We've got a number of clients that are building that out, and this could blow up really quickly potentially. I mean, this could go from onesie twosie units here to 30, 40, 50 100 units a year or more by 25, 26. And if it does that, like this could be on its own tens of millions of dollars kind of business by itself, right? Yeah. And so for that we need to build out the team to that. For that we need capital, obviously, but we're also going to be further going down the path with Space Force. So there's all about creating propellant to drive this refueling in space, and so they're interested in being able to create metal propellant off of materials that are already up there for a variety of reasons. And so we're pursuing that. And there's this project is only 15 months long. It'll be over in May or June of next year. And we want to go for the next level with that, with our partners at Sierra Space and Astroscale and Neumann Space as a supplier for the test thruster there. So we're and Mines, of course, actually on that one we're doing CSU because they're helping us with the testing and stuff. So that we want to turn into StratFi or TACFi kind of opportunity and try to get that into the program of the Space Force and drive really
StratFi and TACFi are where the company finds $1 and they're matched by government money by $2. So that is a giant lever.
I think it's 1-to-1, but it or maybe it depends on how you do it. But
right,
it's matching
1-to-1, 2-to-1, or 1-to-2. Regardless, there's a very large government match to private capital.
And if you do the full size of it and you have the full 1-to-1 match, it's a $60 million potential purse.
Right. Yeah.
That's enough to actually do a mission.
Right.
And if that gets funded, then I would see us going from say the 24 to 25, 26 timeframe, building out an actual test mission where we go up into space with his partners, at Sierra and Astroscale and whoever else we decide to bring on for this part of the project, to actually show that we can capture an object. Maybe we bring the object and release it and capture it, but show that you can capture an object, melt it down, turn it into something.
Yeah.
Also, along the same time, in parallel to this, we're developing the NASA program further, and we've got a plan for a demonstration on the space station in early 2025 of the full-scale space foundry. So what we're testing in November is going to be the device that we take to the space station, hopefully without too many other modifications. And we're going to be testing that on the space station. We got Axiom partnering with us on that one, and Zin Technologies helping us, get it integrated on the space station to do that demo. And then from there, there's an opportunity to offer our first metal processing service in space, which would be, if the Axia module is there in time, we will offer it on the Axia module, and it will be sort of metal processing as a service,
Right.
where we have scrap material on the space station, which you would otherwise have to pay to send down.
Right.
We process it and turn it into materials for in-space manufacturing. And that could be ingots that can be used in the 3D printer. And there is a whole host of other applications that come out of these things. I mean, there are some terrestrial applications we're looking into as well in the mining industry. So there's like it's all built around this one core technology of the Space Foundry and the tech stack that kind of supports that, being a reality. So I'm pretty optimistic about doing this. The trick here is actually like figuring out how to, scale it properly, matching that with the funding at the same time. And it's a tricky balance.
Yeah.
It's not a trivial challenge, but
No, the financial engineering is almost as hard as the actual engineering.
Yeah. Well, raising money is a very time-consuming experience.
Yeah. All right, Gary, thank you very much, sir. Really love having you here. It's amazing watching this story unfold in real time, right? As it's happening. So
Exciting.
We'll keep asking you to come back and just kind of share how this is going. Thank you very much. I appreciate it.
Yeah. Thanks for the opportunity to tell the story.
Right on. Have a great day.
You too.